Hello, I'm Kamira, and in this video I'm going to use DOCROS for drawing the moment curvature diagram of a reinforced concrete section. For this section, I assume this concrete section with the width of 300 millimeters with the height of 400 millimeters and the depth from the top to the middle of the reinforcement is 370 millimeters, and total area of the tension reinforcement is assumed to be equal to balance steel. And now I'm going to use DOCROS for drawing the moment curvature diagram and control the strain in different layers of this cross section. First, we need to create a new project. We need to select name, I call it beam, and then force and unit and tolerance. We don't need to modify these parameters. Okay, and then next. Okay, next is to introduce the material. We can just close this and continue from the edit menu. The second part is material model. In this section we have two different types of material. The first is concrete. I want to use fiber reinforced concrete, and then we have a steel rebar. And also here I want to use high strength strands for pre-stress beam. Now I'm going back to, we have different material model. I want to use nonlinear model 104. If you want to see the model, we can click on help and check the model properties. We need to click on new to select a new material. We need to name it. I want to enter for concrete. EC, I want to use this material model. I introduced it before. It's nonlinear material model 104, and this is the compression and this is the tension, behavior of the beam of the material. And now I'm going to introduce information. EC, I want to enter 35,000. Pay attention that in the compression zone we need to enter minus for the strains because they are in compression. So it's minus 2.6 E minus 3, and for FCC compressive strength is minus 40, and for EC C is minus 3.26 E minus 3. ACT1 is in the tension, so tension zone we need to enter the positive values. It's 1 E minus 3. I just assume these values. These values could be obtained by the Rayleigh test. FCT1 5, it's too high, I will enter 4, and 1E minus 3 minus 3, and FCT2 is 5.9. FCT2 is, I just will put 5.9. ET3 is 2E minus 3, and FCT3 I will put a lower value. It will be more realistic. I will enter 4.5, and for the next one I will put 3 minus 3. Just these values are not realistic. I just want to input these values for the analysis. Okay, so for the next step we want to introduce a different types of material. I introduce 104, we have conch, and for the steel I want to introduce this model. Two is for steel. I want to create a new material. I just put steel and ES. I want to enter 205,000. We don't need to enter the negative value for the compression zone, because just we enter the positive for all values. It will be considered for the compression and tension. 102 ESH, 102 E3, FSY ESY is 7 E minus 3. Well, FSY is 1.T2 E3, 45 E3 doesn't. ESH is 0.021 and FSH is 1.2 E3, and ESU, the ultimate strain, will be 3%, and FSU will enter E3. Okay, now we enter the material. We can go to the next step. The next step is the geometry and their thickness. Here we can divide this section to different layers. For example, these layers 1, 2, 3, 4 to different layers, and we can assign the properties of each layer to the introduced layer. Now I want to use the layer with the length of 300 and with the width of 1 millimeter for the top. So I will introduce the layer and I will name it L1. It's geometry. I will name it geometry 1. Thickness I want to use 1 millimeter. Height for each layer, and the width of layer will be 300. Okay, and I want to introduce a new layer here for the layer with the rebar. The geometry name is G2 for steel. The thickness I want to use, I can use 1 layer or 2 layers for this part, but I want to use just only 1 layer. The thickness will be 200 millimeters, and the width will be 27.9. Okay, I want to modify the first layer. I want, instead of 1 millimeter, I want to use 10 millimeter, equal to 1 centimeters. I want to decrease the layers. Okay, for more accuracy, it's better to use the smaller layer. And in G2 I want to introduce a new layer. Okay, I want to introduce a new layer in G2. Here in geometry 2 we have also concrete. which will be 300 minus 27.9. 300 minus 27.9, it will be 272.1. So the width will be 272, and the thickness of the layer is same as the previous ones, 20 millimeters. And for the last layer, the geometry name, I name it as G3, and the thickness is 10 millimeters because I want to divide it to 3 layers. So the thickness of each layer will be 10 millimeters and the width will be constant 300. Okay. Now we already introduced a layer. We can go to the next step, which is the layer properties. We need to assign the properties, the material of each geometry. We need to select each geometry and tell what types of material already exist in that geometry. First, we need to choose a name. I name it as P1 equal to properties. G1 is only concrete, it's nonlinear material 104, it's concrete, okay. And I want to introduce the new layer for, I want to introduce new properties for layer 2 with concrete. It was G2C 104 and concrete, okay. And another one, P2 steel. It was G2S, the geometry was G2S, the material is steel and it's steel, okay. And the last layer is G3, the geometry is G3, and I want to name it as P3 is properties 3, G3 it's concrete and concrete. Okay, now we already have all layer properties, and for the next step we need to introduce the pattern of layers. As we can see in this image, the layers are introduced from top to bottom. We introduced each layer. Now we need to input the number of layers in the pattern. For example, here the height of each layer was 10 millimeters. We have 360 millimeters of depth, so the number of layers will be 36 layers. I will choose a name. I want to name it as L1. L1 will be, for example, here in this image will be from layer 1 to 6. Name it L1. L1 will be here in these layers. In these layers will be from number 1 to number 36 because each layer had 10 millimeter height and we have 360 millimeters of depth, so the number of layers will be 36 layers. We have 36 layers. The properties is P1. We have just only one phase. We don't want to introduce more phases. We have one phase and the layer is P1. I will add it to this layer. So in L1 we have 36 layer with the height of 10 millimeters. So the height of this layer will be 360 millimeters. So okay, we have another part here in the steel layer. We have two types of material with the height of 20 millimeters. So I name it as L2. The number of layers is one layer because I enter 20 millimeter for the height of layer, so we only have one layer with the height of 20 millimeters. We have concrete, P2 concrete with in phase 1 add, but we also have the axial in this layer. We have concrete and we have axial. So I choose axial and I will add it to this layer. As we can see in the layer properties, we have two properties in phase 1. Okay. Now we have L1, L2. I choose select and new. It is L3 and the number of layers will be 30 millimeters with the height of 10. So we have 3 layers. Is P3 in phase 1. Add. So it's P3 in phase 1. Okay. Now we already introduced all layers 2 and 3. The next step is the layers to analyze. So which layer needs to be analyzed? I want to analyze the layer in the top, on the bottom, and also the layer on which we already have the steel bars. The layer on the top will be the first layer, because if I move the mouse over this part, we can see that it started from layer 1 to layer 36. I can also click on this part and check. So I will choose layer number 1, add it to the analyze layer. Here the layer is layer number 37. So I want to analyze the layer number 37. Add it to the layer, and in the bottom it started from 38 to 40. So the last layer is layer number 40. Okay, and next. The next is pre-stress layer. I don't want to introduce the pre-stress, but for introducing the pre-stress we can just choose the layer. Here for example in the second layer in the steel bar in the 37 we can introduce the pre-strain to which already exists in the steel bars. So I don't want to introduce this layer. I'm going to the loading conditions. We need to enter name for the load type. I just name it as load 1. The pattern name, we had 3 layers, so I want to apply the load to layer 1 and layer number 1, and the increment, extra increment will be 0.001, for example. It depends, it will increase the strain in layer 1 of the pattern 1. It's in the top layer with this value 0.001 in order to obtain the moment curvature diagram. So okay, we only have one load condition here in this case. Next, we need to introduce a stop condition. A stop condition, I want to choose stop 1. Pattern, again I want to control the layer 1 of the first layer here in the top. If the concrete strain reached minus 0.035, so this is the crashing strain of the concrete. So we will increase the strain in the first layer up to this value. It's negative because it's in compression. We will increase the strain, and when the increment reaches to this value, it will stop the analysis. I want to go back and modify the monotonic load because it must be negative because it's in compression, and I want to decrease the value because it will reach to the stop too soon. I want to have the more smooth curve, so I want to decrease it to 0.001. I already introduced a stop condition. And the next step, we don't have a cyclic load. I don't want to introduce a cyclic load. And in the last parts, which is accessible from the last item in the edit menu, is phase data. We need to choose the load type, which in our case is monotonic. The load name was load 1. We can have different load conditions and different stop conditions, but in this case we have load 1 and with a stop 1. Okay, and finish. Now when the model is already generated, we have a data file which can be modified directly, but in this case we use the application interface to modify this data file. After saving it, we can go to run and run DOCROS. We can open that data file. So we have the information of the model. By choosing 1, the calculation procedure will be started. I clicked on 1, and now we can see that we have different increments. It has started from -1 E -4 and increased up to -3.6 E -3, which is more than our stop condition, and then it has stopped. So I click on enter, and then I can click on E and exit from the DOCROS. And now for the report, we can go to the graphic, and in the cross section we can draw the curvature in X direction and moment in Y direction, and when we click open, it will generate an Excel file and will draw the report in Excel file. I'm going to Excel file. When we generate the model, we will have the different information of the model. So this is moment curvature MC. This is the generated file. This is the information. My macro is disabled, so it's not possible to draw it directly in the application. I want to draw it manually. Here in the first column we have the curvature, in the second column we have the moment, and then we have the neural axis depths, and then we have the crack widths. I want to draw the moment versus curvature in different steps. As we can see, the moment curvature diagram has been drawn in this shape. Okay, thank you for your attention.